Ever find yourself wishing you could, like, sculpt your muscles? Not just, at the gym, but, like, at a microscopic level.
Like fine-tuning those fibers for peak performance.
Exactly. It's
Yeah.
kind of like, sounds like something out of science fiction, right?
It does, but get this. Today's deep dive, we're stepping into the fascinating world of muscle fiber transformations. We're talking about those microscopic powerhouses responsible for every move you make and how they can actually morph and adapt based on the type of exercise you put them through.
It is kind of wild when you think about it like that. For the longest time, we thought muscle fiber types were, like, set in stone.
Right. You were either born a marathon runner with tons of those slow twitch fibers or a sprinter with those explosive fast twitch fibers.
Totally. But get this. Recent research is showing us that our muscles are way more adaptable than we ever thought.
It's pretty amazing.
Okay, so before we get into the how-to of these transformations, let's break down these muscle fiber types, shall we? We're talking type 1, type 2A, and type 2X.
The muscle fiber trifecta.
Exactly. Think of them kind of like a car's engine. Your type 1 fibers, the slow twitchers, they're like those fuel-efficient engines.
Diesel engines, they can go the distance.
Yes. Perfect for marathons, triathlons, that sort of thing.
Exactly.
Then we've got our type 2A fibers. These are kind of like the hybrids of the muscle fiber world.
They've got that balance of speed and endurance.
Right. Picture like a balanced gasoline engine can handle both city driving and those open highway stretches.
I like that analogy.
And last but not least, we have our type 2X fibers. These are the heavy lifters of the muscle fiber world.
Those high-performance engines.
Yes, built for those short bursts of intense activity. Like, imagine sprinting for the bus or pushing for that personal best at the gym. These fibers burn through fuel quickly, but they pack an incredible punch.
They do. Great analogy to kind of lay out what each fiber type does. And while it might seem simple on the surface, figuring out someone's muscle fiber makeup is more complex than you might think.
Oh, really?
Yeah. For example, one way scientists do this is by analyzing homogenized muscle samples. Think of it like blending the whole muscle into a smoothie
Okay.
and then analyzing that mix. But this approach, while common, it often misses a really important detail.
Okay, you're telling me there's more to the muscle than meets the blender. What am I missing here?
It's more about what gets missed. Traditional analysis often overlooks hybrid fiber.
Hybrid fibers.
Yeah, and these things are fascinating. They express characteristics of different fiber types, which makes them, like, incredibly adaptable. Imagine, instead of analyzing the whole smoothie, you analyze each ingredient in that muscle smoothie separately. That's single fiber analysis. Super detailed, but it gives us a much clearer picture.
Okay, so we've got our muscle fiber types, we've got our super detailed analysis methods. Now for the million-dollar question. How can different types of exercise actually reshape those fibers?
This is the question.
Yes. So let's start with everyone's favorite pumping iron. What's the deal with resistance training?
So when it comes to resistance training, we're talking those heavier weights, fewer reps kind of exercises. And studies are showing that this type of training encourages a shift from those powerful type 2X fibers towards those more enduring type 2A fibers.
Hold on. So does that mean if I'm all about that heavy lifting life, I'm destined to, like, lose my explosive power?
Not necessarily. While there is a shift towards type 2A, it doesn't mean you completely ditch the type 2X fibers. It's more like those fibers are being trained for better endurance. And as a bonus, it can actually boost your overall strength gains over time.
Interesting. So it's kind of like taking your sports car on a road trip. It's still got that horsepower, but now it's got much better mileage.
Exactly. But here's where it gets interesting. A study by Liu and colleagues, they compared traditional strength training to a combo of, like, ballistic, plyometric, and strength exercises.
Okay, I'm intrigued. What happened?
So get this, the combo training, it led to less of a shift towards type 2A fibers, suggesting that incorporating a mix of exercises into your routine might be the key to holding on to those powerful type 2X fibers while, building overall strength.
So variety truly is the spice of life, even when it comes to our workouts.
Mm-hmm.
Don't just stick to the same old routine. Challenge those muscles in new and different ways.
I couldn't agree more.
Now, switching gears to another workout that's been shaking things up in the muscle fiber department, sprinting. You might think, this would be all about those fast twitch fibers. But the research, well, it tells a different story.
It really does.
Hit me with it. What's the deal with sprinting and muscle fiber types?
Well, just like resistance training, sprinting can actually increase those type 2A fibers. But here's the mind-blowing part. Even those endurance-loving type 1 fibers, they can get in on the action.
Wait, are you serious? Those slow twitchers are adapting to high-intensity sprints. That challenges everything we thought we knew about muscle fibers. It's mind-blowing.
It is. A study on male sprinters by Anderson and colleagues demonstrated this perfectly. After just 8 weeks of training, there was a significant shift from type 1 towards type 2A fibers. So, yeah, those fibers are way more adaptable than we ever thought.
This is incredible. Okay, so we've seen resistance training, sprinting. They both lead to an increase in type 2A fibers. What happens when we hit the endurance training? I'm thinking this is where type 1 fibers really shine.
You got it. Endurance training, things like marathons, triathlons, they heavily rely on those slow twitch, fatigue-resistant type 1 fibers. They're all about that maximizing oxygen utilization, keeping you moving for the long haul.
Makes sense. I mean, you need those efficient engines to go the distance. But what's the evidence for this?
Oh, it's more than just a hunch. There's a study by Luden and their team, and they followed a group of first-time marathon runners, for 13 weeks of training. And get this, they discovered a huge increase in type 1 fibers in the vastus lateralis muscle.
And that's like a key player when it comes to running. So talk about proof that logging those miles really does transform your muscles for endurance. But what about like a more personal look at this, like the impact of long-term endurance training on, individuals?
Well, there's this fascinating case study, A Tale of Twins, that really illustrates this.
Oh, the classic twin study.
Yeah. So one twin, they lived a pretty sedentary lifestyle.
Oh.
While the other twin, they were a dedicated endurance athlete.
Ah, so we're really seeing that nature versus nurture thing play out. What did they find?
Well, the results were, pretty striking. The athletic twin had way more type 1 fibers compared to their more sedentary sibling.
Wow.
Yeah, it's a powerful example of how, years of dedicated training, it can really reshape your muscles. I mean, we're talking at the most basic level.
That's incredible. But let's shift gears a little bit here. What happens when we take a break from training? Does everything just revert back to its original state? Or is there more to it than that?
Well, that's where things get even more interesting. You see, we used to think that if you take a break, your muscles just went back to how they were before you started training. But turns out that's not always the case, especially when it comes to those powerhouse type 2X fibers.
Wait, so you're saying even after we stop hitting the gym, our muscles might still be packing some, hidden power? Tell me those type 2X fibers are holding strong.
You better believe it. Studies show that after periods of, what we call detraining at Keiko, there can actually be a temporary increase in type 2X fibers.
Really?
Yeah. And sometimes they even surpass pre-training levels. It's like they're staging this comeback tour, ready to fire up those fast twitch engines when you least expect it.
Okay, now that is wild. It seems, I don't know, kind of counterintuitive. You'd think taking a break would mean fewer of those powerful fibers, not more. So what's the science behind this? Why would our bodies do that?
Yeah.
Well, we're still trying to figure out all the details, but one theory is that it's the body's way of, ensuring that we can still generate that rapid force, even when we haven't been actively training for it.
Makes sense.
Because those type 2X fibers, they're essential for those bursts of power we need for everyday life, right?
Totally, like sprinting to catch the bus or, quickly lifting something heavy.
Exactly.
So even when we're taking it easy, our bodies are still looking out for us, making sure that we're ready for whatever life throws our way.
Yeah.
But what about those dedicated athletes who, they incorporate those planned breaks into their training?
Right.
How does this, this whole type 2X overshoot thing, how does it factor into their performance?
That's a great question. Well, let's take marathon runners, for example.
Okay.
They often use this technique. It's called tapering.
Right.
And basically what they do is in the days leading up to a big race, they reduce their training. The idea is to let their bodies fully recover, so they're in peak condition come race day.
Yeah, makes sense. You want those muscles to be, primed and ready to go. But how does that tie into this type 2X fiber overshoot?
Well, studies have actually shown that during this tapering period, even though marathon runners are, cutting back on their training volume, the functional characteristics of their type 2A fibers actually improve. They display greater power output, which can make a real difference, especially in those final sprints to the finish line.
That's incredible. So even though they're, focusing on those slow twitch fibers for endurance, this taper period allows those fast twitch fibers to, recharge, Be
Good.
ready to fire when it matters most.
Exactly. And it kind of highlights a crucial point about muscle adaptation, right?
Okay.
It's not just a simple case of one fiber type being replaced by another.
Right, right.
It's way more nuanced than that. You have these different fiber types adapting and interacting with each other in these really complex ways.
Fascinating. But like, how does all of this happen? What's actually going on at a cellular level to make these transformations possible? What's going on behind the scenes of this whole muscle fiber makeover?
To really understand that, we got to zoom in on the microscopic world of, nerve signals.
Okay.
It's those electrical impulses that basically tell our muscles to move.
Right.
It's like the communication highway between our brains and our muscles.
Yeah.
Every contraction, every flex, it starts with a signal from our nervous system.
So are you saying if we can, like, change the signals we're sending to our muscles, we could actually influence their fiber type?
Mm-hmm.
Is our brain like the ultimate personal trainer?
That's the question, isn't it?
It is.
And early research into this involved some, I have to say, pretty wild experiments. Scientists were literally swapping the nerves that connect to fast-twitch and slow-twitched muscles.
Wait, hold on. They were like rewiring muscles. That sounds like something straight out of Frankenstein.
It does sound kind of wild, right? But it was groundbreaking research. When they connected a slow twitch muscle, like, for instance, the soleus muscle in a cat, to a nerve that's usually linked to fast twitch muscles, that slow twitch muscle started to develop faster twitch characteristics.
Whoa.
And the reverse happened too.
Wow. Talk about a nervous system makeover.
Yeah.
But you said earlier that it's not just about the nerves, right? There's more to it.
You're right. While those nerve swapping experiments were, revolutionary for their time, more recent research has shown that there are other factors at play here. We're talking about what's happening inside those muscle fibers themselves.
Okay.
Intricate signaling pathways, that get activated by exercise.
Right.
They play a huge role in all of this.
Sort of like zooming in on the microscopic world inside those tiny muscle fibers.
Exactly.
It's like watching this cascade of cellular events all in response to our workouts.
Precisely. And two key players in this whole microscopic world, they are calcium and a molecule called AMPK.
Okay, calcium, like what's in milk? And AMPK, that just sounds like some, I don't know, supercharged energy drink for our cells.
Not quite, though I do appreciate your enthusiasm. So calcium, it plays a really important role in muscle contractions.
Okay.
It acts as a messenger, basically helping to get the whole contraction process started. And when we exercise, especially endurance-based activities, our muscles experience this like surge in calcium.
It's like a signal flare, right? It's telling those muscle fibers, hey, we're in endurance mode. It's time to adapt.
That's a great way to put it. And this calcium surge basically sets off this chain reaction, and ultimately it influences which genes are turned on or off within those muscle cells,
Oh, wow.
including the genes that, determine fiber type.
Okay.
And one crucial pathway that's involved in all of this involves a protein called NFA.
NFAT, got it.
And scientists have actually found that if they block this pathway, it prevents that shift towards those slow twitch fibers.
Wow. So it's like NFAT is like the construction manager, receiving those calcium signals and overseeing the entire muscle fiber remodeling project.
A perfect analogy. Now, AMPK, this one is more like a fuel sensor for our cells.
Okay.
It gets activated when energy levels are low, like, during a tough workout.
So when we're pushing our muscles during a workout, AMPK is there to save the day. What does it actually do?
Well, AMPK, it's really important for boosting energy production, and it also increases the number of mitochondria in our cells.
Oh, mitochondria. Those are the powerhouses.
Exactly. They're responsible for generating energy. And, guess which type of muscle fiber just loves having lots of mitochondria?
Tap one, those endurance superstars.
You got it.
It's all making sense now.
And, studies have shown that if you inhibit AMPK, it can actually reduce that shift from fast twitch to slow twitch fibers. So it really highlights how important AMPK is for muscle adaptation.
This is incredible. So we're like these incredible adaptable machines just responding to the demands we put on them at like a cellular level.
It's pretty amazing, isn't it?
It is.
And it gets even more interesting when we bring genetics into the picture.
Okay.
Because even in this, microscopic world of muscle fibers, our DNA still has a say in how things play out.
So even with all this amazing adaptability we've been talking about, our genes still have some say in the matter.
Absolutely. Our genes are a big part of why our baseline muscle fiber composition is the way it is. For example, there are variations in genes like ACTN3 and ACE, and these variations have actually been linked to like differences in fiber type distribution between people.
So are you saying that some of us are, like, genetically predisposed to having more of a certain fiber type? Like, we're destined to be,
Yeah.
a marathon runner or a sprinter from birth.
That's a great question, and it's something that scientists are still trying to fully understand. It seems like our genes kind of lay the foundation,
Mhm.
and then our training, our lifestyle choices, they act as the architects, shaping our muscle fiber profiles over time.
It makes you wonder, what if we could, like, hack our muscle fiber types?
Mhm.
Imagine being able to just, I don't know, optimize your muscles for a specific sport or activity.
That would be something else, wouldn't it? We may not be at the point where we can like custom design our muscle fibers,
Right.
but the more we understand about how they adapt, the better equipped we are to, train smarter and really, optimize our performance and crush our fitness goals.
This deep dive has been amazing. We went from those, like, basic muscle fiber types
Yeah.
to, like, the nitty-gritty, the cellular adaptations, the overshoot phenomenon.
Mhm.
It's really been incredible. So if you had to leave our listeners with one key takeaway, what would it be?
I would say, above all else, remember, your body is incredibly adaptable.
It really is.
No matter where you're at in your fitness journey, whether you're a seasoned athlete or just starting out, your muscles have this incredible capacity to change
Right.
and respond to the demands that you place on them.
It's empowering
It is.
to know we have that much control, even at a microscopic level.
You have more power than you think.
I love that. This has been an awesome journey into the world of muscle fiber transformations. I don't know about you, but I'm ready to hit the gym.
Me too.
Thanks for joining us for another Deep Dives, everyone. Until next time, keep exploring and stay curious.